I'm very proud of the warriors from me being from Bay Area. I'm not talking about the Golden State Warriors. I'm talking about the networking warriors, each one of you and those of you on the video. Because of you, I and my wife could keep our jobs. My mom could upload her cooking videos, and my 10-year-old son, most importantly, he could play Roblox during the COVID pandemic. Thank you for each and every one of your contribution. So I'm Kiran, Head of Marketing at Anuta. In the next 15 minutes, I will introduce our product, Anuta ATOM, and then a couple of exciting demos right after my presentation. This is the agenda. I will introduce our main offering, Anuta ATOM, our customer deployments. So some of you are familiar with Anuta Networks. We focus exclusively on closed-loop network automation for multi-vendor, multi-domain networks. Our target customers are service providers and large enterprise. You can see some of our publicly referenceable customers here, and I have a couple of case studies for these customers as well. Our primary offering is Anuta ATOM. It is delivered as a cloud-native Docker containers, so it can support various microservices. So it's a software solution, but it has multiple modules, as you see in this diagram. It helps with complete network automation, all the way from onboarding the devices, maintaining the life cycle of the device, upgrading the software, provisioning services, and finally monitoring the health of the service and taking any remediation steps. It supports multi-vendor, multi-domain, and multi-tenant networks. So it can be deployed in multiple form factors. It can be deployed on customer locations. It can be deployed on cloud. Anuta also has a SaaS offering, Atom Cloud. I wanted to take a step back and notice how we always announce all our major features coinciding with Networking Field Day in January. In NFT 14, we introduced Anuta NCX, which features Yang service orchestration. In NFD 18, we pivoted to microservices-based architecture and introduced Anuta ATOM. We added telemetry, analytics, and closed loop with workflows. A couple of years ago, during the COVID pandemic, we announced Atom Cloud, the SaaS offering. We added exciting use cases like zero-touch provisioning, OS upgrade, and out-of-box services. Now I'm delighted to share about the exciting feature of active service assurance as part of today's release. We also have some powerful features that my colleagues will walk through in the demo as well. This slide captures the overall end-to-end network automation flow. Atom can be deployed in the cloud, and there are Atom agents that sit next to the devices. So it starts with onboarding the device. This could be your greenfield deployment, in which case Atom can run through the ZTP flow, or it's a brownfield deployment, then Atom will discover using CDP, LLDP, etc. Once the device is onboarded, Atom is maintaining the state of the device. It captures the config archive, it compares against golden templates and detects any deviations. It also builds the layer 2 topology. So once it has full device state, it can provision services. So it can run pre-checks using the workflows. Only when it's successful, it continues to provision services. This is where it can provision layer 2, layer 3 VPN services, firewall rules, load balancer policies. Once the service is provisioned, it can run post checks. make sure the service is correctly configured on the device. After that, the active service assurance kicks in, and active service assurance kicks in, and that's where it can generate synthetic traffic and measure the end-to-end throughput, latency, and jitter to make sure the service matches the SLA promised to the customer. If there are any deviations, then the workflow will get triggered and it will take the remediation steps. And that's how we offer end-to-end closed loop automation. Let's apply this to a use case like layer 2, layer 3 VPN. So the pre-checks could be like, before you provision, you want to check, is the device online? Does it have capacity? You can take a snapshot of the device, maybe the number of BGP neighbors, etc. And then the service activation is where it can provision the actual VPN commands to the devices. If it's a Juniper device, it provisions netconf payload. If it's a Cisco device, it provides the CLI. Then the post checks again takes snapshot of the configuration, compares with the state before provisioning. It can run some ping test, make sure the service is active. Then active assurance could be about running some TCP tests, maybe a TWAMP test, maybe bandwidth test, like that. And closed loop remediation could be like an example where, let's say you have a QoS policy and that's blocking the throughput, then Atom can remove that policer, for example. So like that, we can apply different set of criteria in each stage of network automation using Atom.
The pre and post all out of the box, or are they all customizable? Your customers can put in whatever they want for these pre and post checks?
So the pre and post checks are based on a workflow engine. And so it is completely flexible. There are out of box, so you don't have to start from scratch. At the same time, you can take these existing out of box pre-checks and you can customize them.
Okay.
And it uses the BPMN language to do that.
Okay, thank you.
So these are the top use cases. I just explained L2, L3 VPN, but similar concepts. You can use the same stateful services for network slicing, firewall as a service, load balancer as a service. And the workflow engine can be used for pre-checks, post-checks, software upgrades, zero-touch provisioning. These are the stateless services. You just provision once and you are done. And then the other popular use cases are zero-touch provisioning, OS upgrades, and then compliance management. Not all the customers are into closed loop, but those of them that have confidence in automation can go ahead with some rules-based remediation. Atom can open tickets in ticketing systems like ServiceNow, so it can provide semi-automated remediation as well. To your question, so there are 225 such out-of-box use cases, and they work for multi-vendor infrastructure. We support 45 different vendors, 150 plus platforms across all the domains: core, transport, data center, WAN, edge. There is a link here with the full list of all the out-of-box services, workflows, etc. This goes into more technical details, how all these modules are interacting with each other. The front and center is the workflow engine that ties with the rest of the modules in Atom. And the workflow can invoke the service model. That's where you can use open config models or IETF models for layer 2, layer 3 VPNs, EVPNs. That gets translated to the device models. So we support device native YANG or open config models for that. And that are translated to the underlying infrastructure, could be CLI for legacy devices, netconf for Juniper type of devices, API, etc. So you will notice that all the modules use the open standards wherever possible. So that way we can interface with variety of third-party software in the customer environment.
So Kiran, is this how you're doing the multi-vendor support then? Everything's got to have a model? The vendor product has to have the YANG model?
Yes. So if the device has a Yang model, our integration is fairly straightforward. Within minutes, we can do that. But if the device doesn't have a Yang model, that's where we have built the CLI adapters for many of these vendors.
Okay.
API integration is also straightforward. If the device supports Swagger API, then it's like instantaneous support for those devices. All the modern devices have the native Yang models, so that's how the integration is quite straightforward. Then Atom can collect telemetry using SNMP streaming telemetry gRPC. It stores everything in time series database like Prometheus. And using the alert manager, it can trigger the workflows to generate the closed loop use cases. Northbound, we have REST API and also support for TMF APIs. So that's how we can integrate with variety of service providers based OSS, BSS layers. In terms of the architecture, it's completely driven by microservices. All the components, the workflows, assurance, compliance, uh, device discovery, these are all microservices in Atom. So that means Atom can scale each individual microservice based on the health of the microservice. So it has self-monitoring and self-healing capabilities. Atom can run third-party software also as microservices in its overall ecosystem. Because of this architecture, we have a lot of advantages. We can provide geo-redundancy, high availability, role-based access, multi-tenancy, and disaster recovery as well. I will share 4 different customer deployments that illustrate the flexibility of this solution across a variety of industries. The first one is a tier 1 service provider in the US. They have rolled out 5G to 50 different cities, 15,000 sites. To do that, they had to integrate with 13 different vendors. So Workflow Engine was the main use case. We automated the end-to-end cell site onboarding process. And because of that, we eliminated manual processes, accelerated time to market, and also reduced the overall OpEx. They use the industry standard ORAN architecture. So all the components are deployed in a public cloud like AWS. This goes into a lot more details of the workflow. It starts with the field operator, that is rack and stack the cell site router. And once they connect it, it makes a call home to Atom's workflow that is in the AWS cloud. From there, Atom talks to the Cisco NSO to provision the base commands on the device to make sure it has the required connectivity to the cloud. And once Atom can connect to that cell site router, it reaches out behind that cell site router. There is a bare metal server. That's a Dell server or a Supermicro server. And the workflow will go through server lifecycle. It will install the BIOS, it will upgrade the Pixie boot and then firmware on the device. Then it will also install the hypervisor, the vCenter, ESXi. It installs the Kubernetes on that bare metal server. And then it fetches IP addresses from Infoblox. And finally, it installs the radio elements, the Mavenir and Altiostar, as the CNF functions. So it's a really complex process where Atom, as it's executing through the workflow, it updates the Slack with notifications, opens tickets in Jira, and updates the inventory in Sienna Blue Planet. So this is how we are able to support a really complex network with workflow engines. The net result is that Atom reduced the time to onboard a cell site from 26 hours per site to 2 hours per device. That means we save 24 hours per site. And when you have like 100,000 such devices, the cost savings add up significantly. Atom accelerated time to deployment and eliminated the manual operations. GAR Consortium is a research network in Italy spanning 1,000 sites. So when they wanted to refresh their hardware, the backbone, they wanted to deploy the spine and leaf architecture with clause topology running EVPN over MPLS. So in that RFP, they specifically wanted automation to introduce self-service for the backbone operations. So if you see the diagram here, Atom provides a self-service GUI. The operator simply enters a few parameters related to EVPN, and within minutes, it translates to the netconf payload to the various spine, leaf, core, and edge routers. They also automated the OS upgrades, zero-touch provisioning, and compliance for this massive network. Because of the automation, they were able to support 60% hike or spike in their traffic with the same number of staff. This is Airtel Africa. They provide integrated voice, video, and mobile data services. And they support 14 different countries in Africa. So when they are refreshing the hardware, they wanted to have a unified strategy across 14 different countries. So they introduced the standard service provisioning for backbone VPN services, service monitoring to measure the health of these VPN services, and also software upgrades. So they automated various use cases. It's around 250 Juniper devices, as you see here. And they also implemented closed loop automation to reduce mean time to repair. This is the final case study, Tata Play. It's a direct to the home service provider in India. So when they refreshed their 400 gig metro network, they introduced Atom for automation. It helps with device lifecycle management, OS upgrades, configuration management, and zero-touch provisioning. I have a lot more case customer details here. Atom has been deployed in variety of domains, 5G, EVPNs, Metro Ethernets, BNG, TMF. And because of the microservices architecture, customers can pick and choose which modules of Atom they would like to deploy. And our pricing as well as our software footprint can be customized according to the modules that they want. I also highlighted the third-party integrations that were deployed as part of these customer environments. So in summary, Anuta Atom delivers end-to-end network automation. It has significant out-of-box functionality. It's based on open standards. And because of the cloud-native architecture, it can be deployed on customer locations, on cloud, and we also have a SaaS offering. In the next few presentations, my colleagues will go through the latest active service assurance feature, as well as a demo.
Kiran, you talked a lot about service provider use cases here. Is that your primary market?
Service providers and large enterprises who want to manage their VPNs, as well as firewalls, load balancers, and EVPN is one other
You do play well with enterprises then,
Yes.
but typically they're going to be larger that can
yes.
leverage this. Yeah.
And Kiran, you mentioned that Atom is built off of microservices, and customers can also run third-party software as microservices off of Atom. Can you give any examples of what customers are using on the Atom platform that's third-party software?
So at the moment, we don't have a customer that's actually running, but the technology is there to run
Okay.
third-party
Thank
software.
you.
Kieran, there is a slide somewhere towards the beginning, lots of flow diagrams that were kind of hidden up in the top there. Is that just like an illustration that looked cool, or is that part of the product? There were boxes and arrows and things going everywhere.
Let me go back, please.
I think that's a big dip and I think that's
This one?
That one, yeah.
Sure. Yes. This is part of the product. So you'll see the workflows. Today, we won't go into how to build those workflows, but definitely it's graphical, very flexible. You can drag and drop and create it.
Neat. Okay.
You said cool or complex?
Sorry, I look.
You said cool or complex or both?
I think I said cool. Let's go with cool.
Yeah.
One more question on the microservices, the back end. Is that just Kubernetes under the hood, or is it something else?
Yeah, Kubernetes.
Okay.